Good morning, everybody. Welcome to our webinar on how to extend DevOps practices to the database. Today, we're going to talk about some of the common challenges that database shops face on their DevOps journey, and also look at the demo of how Redgate can help. So a couple of housekeeping items before we get started. Everyone will be on mute during the webinar, but we want to hear your questions. So if you have any during the course of this presentation, please enter it into the GoToWebinar question box, and we'll make sure that we leave plenty of time at the end to go over them. This webinar is also being recorded, and we'll follow up with a copy of the recording as well as the slides over the next couple of days. My name is Arneh Eskandari, and I'm the head of pre-sales engineering for the North America region here at Redgate. So I've been with the company for just over 7 years, and as part of my role, I've helped hundreds of organizations across different industries implement DevOps best practices and streamline their delivery processes across their application and databases. So here's my contact info, and if you have any questions, please feel free to reach out. Here's a quick agenda for today. So I'd like to spend the next 5 to 10 minutes setting the scene and talk about the common challenges that we typically run into on database change management, and then spend the rest of the hour demoing how Redgate can help with database DevOps. So just a quick one on Redgate for those of you who are new to the company. We've been around for just over 18 years, and as of now, we have over 200,000 customers. We offer tools and solutions to help companies improve the quality and efficiency of their SQL Server database development and deployment processes. We have a pretty big presence in the community as well through our SQL Server Central and Simple Talk hubs, where we share best practices, trainings, and really helping to solve problems with the database community. We also sponsor a lot of free events such as SQL Saturdays, and even host our own Redgate specific one, SQL in the City. And actually, you might be interested to know that we are hosting a couple pretty soon in October, and I'll be sharing the details on those events with you towards the end of our webinar today. The other thing that I'd like to draw your attention to here is the number of product releases from last year. So at Redgate, we do really practice what we preach, and as you can see, we've had over 1,000 minor and major product releases last year alone, and that's a number that just seems to be increasing year on year. And finally, our customer ranges from global corporations, 91 of the Fortune 100, all the way to single shop persons and everything in between. Okay, I'm sure that most of you have a good idea of how DevOps works and what it is. However, applying these same principles to the database can be a real headache, as it is not as straightforward. So why is that? And ultimately, a database is a complex beast and always holds data and state that needs to be preserved, right? So let us imagine a scenario for a moment. We want to make a change to our application codes, let's say. A lot of dev shops out there are already using best practices around application lifecycle management and rapid delivery of their application code, such as source controlling, unit testing, automated tests as part of the build process, etc. So that changes can be deployed very quickly. We change the line of code, check it into source control, that gets basically triggers a build, some automated test run. If everything looks good, then that change just gets moved up the chain to higher environments. For databases, however, a similar level of change will often involve a lot of manual steps. A developer manually saves off the scripts for their changes, maybe put them in source control, maybe not, and later submit to a DBA team or operations team through a ticketing system or other means for review and execution against higher environments. That may or may not be in sync with production. Ultimately, though, deployments of databases are not as easy as swapping out old code with new, and this is our fundamental problem when it comes to databases. We can't simply swap out table, for example, especially as databases hold business critical data that needs to be safely preserved, right? So ultimately, because of the unique challenges with database delivery, this means that often we find the database is left out of this process. And because of that, we come across a lot of dev shops who've experienced a whole host of issues. To begin with, databases are always out of pace with application development. This undermines the DevOps adoption we're seeking to push forward with, as changes that are made with the application code can be held back by the database, due to the changes taking longer to push out, obviously. In other words, databases become a bottleneck in your agile delivery process. Because of this, releases are less frequent, and therefore we need to push out large chunks of changes out in each release, which makes them more risky. Not only for the database itself, but also any code that relies on the database changes, which can often be the majority. We're preventing the use of CI/CD and putting manual steps into what should be an automated process when it comes to databases. This then means that each deployment requires a lot of dev and DBA hours, which is what we were trying to avoid in the first place. They become stressful, demoralizing, and all hands on deck type of a thing. If something does go wrong, then we often have no way of tracking database changes. This can make bug hunting a nightmare. In some cases, we can't even test the production readiness of our changes against a true copy of production before going live, which means that we need to keep our fingers crossed and have a good rollback strategy in case our deployments to production don't go as planned. As part of our database delivery process, we need to make sure that we are executing the right changes on our target databases going all the way to production. We also need to make sure that we have the changes from all developers in the right order. That on its own normally is a very time-consuming task, because I've seen where a specific shops where a specific person is simply responsible for consolidating everyone's scripts together and ordering them and making sure that those scripts are valid and that they're going to deploy successfully. So these are quite common challenges that database shops run into on daily basis, and that's really the reason why we're really keen on bringing the database into our DevOps world. But enough of the negatives. What would we see if we could do DevOps for the database? If we could bring the data set into this process, what we see is that we would be able to build repeatability into our delivery process. This means that we can continuously test the production readiness of the changes that we apply to our databases, and this affords us much great predictability, greater reliability, and also faster response time. Deploying small units of changes is really the key principle when it comes to DevOps. I talk to database shops, specifically DBAs, almost every day, who are required to review thousands of lines of scripts when it comes to deploying the database. That normally can take days depending on how many bugs exist in that code, and how much back and forth we need to have between the operation people and the developers to finally be able to deploy those changes out. So now, by committing small database changes to source control on a regular basis, which should be your starting point, you can introduce automated builds and tests to make sure that all of those small units of changes are tested and validated. This often happens multiple times before you're even ready to deploy from your dev environment to the next environment. And that can result into your releases being more reliable and less time consuming as a result. Overall, everyone is a lot happier. Developers are happier, as the database is no longer a bottleneck. DBAs are under less pressure and performing less boring and repeatable tasks, so they're happier. And most importantly, the end users are happier, as they get new features quicker, and known issues get cleared out sooner, and their feedback loop can be greatly reduced. Everyone loves it when a change is requested, and then they see that change promptly. And finding another great benefit of being able to respond to a changing landscape quickly is that suddenly our big compliance question can be answered sooner. It is now easier for us to adopt these compliant best practices that were maybe an afterthought beforehand, and we can go further by ensuring the steps we are taking are also compliant in and of themselves. A lot of you might already be familiar with the GDPR, which is the General Data Protection Regulation that became enforceable back in May. In the GDPR, requirement of data protection by design and default actually aligns really well with the core fundamentals of DevOps. Having a reliable, repeatable, and auditable process provides a solid foundation for us to meet these requirements. Automation can help us provide a robust and repeatable audit trail, for example, with our changes, among other things, being tracked at all stages. We can now see, who did what, when, and why. In addition to this, by extending DevOps practices to the database, we no longer have to wait until the point of release to see how our software behaves. We know what to expect and reduce the risk of chaotic or even catastrophic software releases. This is a key, as a catastrophic failure can actually result in a data breach. And you might be wondering how. Well, the definition of a data breach, according to the GDPR, actually includes loss of access to data. So simply having an environment unreachable can land you in hot water. With the robust change control and testing, however, we can ensure that we remain reliable, repeatable, and consistent. And of course, this is a really big focus for people at the moment, but don't just take my word for this. Every year, Redgate runs a survey of database professionals and produce the state of database DevOps report from the data that we collect. Some of the key findings from our 2018 report are that within 2 years, over 80% of companies will adopt DevOps. The biggest driver for including the database is the increase of speed in delivery of database changes. And finally, 76% of respondents have developers in their team who work across both application and databases. So we no longer see, these specific SQL Server developers and the specific application developers. And that's another really great reason why we need to, streamline the processes that we follow for change management between the application code and the database. So if you guys want to learn more about this report, you can visit our website to download the full report, and you can see the link here at the bottom that you will get access to once we share the recording and the slides. So how can Redgate help? So this diagram is basically our preferred workflow when it comes to database change management. So the top line is basically a common change management process, regardless of whether you're working on the database or the application code, right? So as development team, you have to check your changes into source control. Source control has to become your, source of truth, and then you can then start looking into automated testing, automated builds, and eventually automated releases to your higher environment. So if you're not source controlling, you don't even need to kind of worry about automated builds or releases. That's really the first place to look at, or the first step to look at. But for databases, the bottom line is critical. So how do we, spin up our environments? How do we provide development environments to our developers, or even testing environments and staging environments, for example? So we're going to talk a little bit about that as well as part of our demo. So this is the kind of the cycle that we want to create, and hopefully by the end of our demo today, you'll see exactly how Redgate can help you implement this. So let's go ahead and take a look at the a demo here. So let me share my other screen here. Okay, perfect. All right, so here I have an existing project that I'll be working with. Now, for those of you who have been on, who have attended our previous webinars, so we used to, so there are two basically flavors to database change management that we offer as part of our Redgate solution. One is a model-based first approach, where we are storing the definition of your objects as create scripts in source control, and then later on relying on a compare engine to compare the state from source control against a target environment to generate the actual deployment script and push those changes out to our environments. The other flavor is the migrations first approach, which is what I'm going to focus on today. So as we're doing this, I'll also talk about kind of some of the benefits of doing migrations first versus model based, and when you'd be better off using which approach. So here I already have a project. I also have a couple of databases that I'll be working with here. So here I have a couple of databases for the Stack Overflow database that we'll be working with. And here I have a project that which is a Visual Studio project through our SQL change automation, as you can see here. So the way this works is I need a development database. I make my changes against that database. Then I use this project to capture my changes into migration scripts, and I'll be relying on Redgate SQL Compare to help me generate those scripts for me. So as a developer, I don't need to manually keep track of my changes and manually save my scripts off. And then once our changes are in source control in our project and then in source control, then we're going to trigger builds and look at how we can automate some of our tests and validations through VSTS. So we're going to use VSTS end-to-end for source control. We're going to use Git in VSTS, and we're going to be doing our builds and releases in VSTS as well. So the first thing you notice here is that it cannot find a database for me to work with. So as a development database. So it's, again, for any database shop, it's a very common practice for us to have a shared development database that everyone makes changes to directly. For a couple of reasons. One is, the primary reason is for us to have, as close, amounts of data as possible to production. So in that case, obviously, it wouldn't make sense to have a large database sitting on every developer's machine. The other scenario is just collaboration, right? If you don't have a good source controlling strategy, then really the only way you can get your database developers to collaborate is to get them to work on a single database. So, but obviously there are a lot of challenges and bottlenecks with that process. You see developers constantly stepping on each other's toes, losing changes, and basically not being in control of their development environment. So in order to prevent that, I'll be using Redgate SQL provision tool to just spin up a quick development database for myself from an image of our production environment. So I'm just going to go ahead and go to my SQL clone here, and I'm just going to go ahead and create a clone of this 100 gig database that basically is representing our production database. So I'm just going to go ahead and create my development database here on my SQL Server on my laptop. Let's just call this Arneh Dev. Okay, so here I'm spinning up my dev database. And as you can see, I already have my database spun up on my SQL Server, and it's only taking up this much disk space on my laptop. So I don't need to worry about, the size of the database, whether it's, hundreds of gigabytes or even terabytes. It's only going to take up, tens of megabytes on my machine. So this is how our solution to how you can easily provide dedicated databases that don't take up a lot of disk space. And you can also make sure that they are masked by applying a masking set to the database. So the sensitive data that resides in your production database is protected as part of your provisioning process, which goes back to our whole compliant DevOps story. So I'm going to go ahead and change the connection to the database that I just spun up. All right, now you can see it's telling me that there are some pending changes in my project that I need to deploy to my database first. So I'm going to go ahead and do that. So since my database is a copy of production, there are some changes in our project that haven't been applied to production yet. So it would make sense to bring my copy of production up to date with what we have in our project before I start making any changes on top of that. Okay, so it's now basically doing a deployment against my database that I just spun up. And it was successful. So if I go back to SQL change automation and refresh, I shouldn't see any pending changes or differences anymore between my project and my development database. Perfect. So now I can go ahead and start making changes on top of what we have in our database. So I'm just going to do that from Visual Studio. It doesn't matter where you make your changes from, whether it's SSMS or Visual Studio. We don't care. Okay, so here's my database. So let's go ahead and make some changes. So I'll make a couple of data change schema changes as well as data changes to lookup tables. So let's start off by modifying this table and add a new column. Okay, so here we have our SQL prompt tool, which has included as part of the solution that makes it really easy for you to write SQL. And this is available both in SSMS and Visual Studio. So I'm going to select the table that I want to modify. And as you can see here, it shows me the content of the table in terms of columns and the types of data they accept. So I can easily see what I need to add here to this table. So I'm going to add a new column. Let's add a new one for Instagram. Okay, let's also go ahead and modify one of our programmable objects here. And I'm going to format it using SQL prompt. Make sure it looks good. You also notice that some of the lines have a green squiggly underneath. This is another feature of SQL prompt, which is our static code analysis. So it basically makes sure that you're always following best practices, and if any of your code doesn't do that, then it will tell you what what you can do to improve your code. So here it's just saying that I don't have a begin and end in the body of my store procedure, which is a good practice to follow. So there's a lot of different rules that you can either enable or disable for your team. So if I go to SQL prompt and look at the code analysis rules, you'll see that there's a ton of different types of rules that you can enable for your team, and this is actually a nice thing because you can also even run these tests automatically as part of your build. So a lot of these rules is stuff that DBAs typically look out for manually when they're reviewing scripts that come from a development team. So by enforcing these rules, you can actually help the DBA save time when it comes to reviewing scripts, and also making sure that you're always following best practices starting from development. Okay, let's go ahead and make this change as well. And I'm also going to add a data to one of my lookup tables as well. So using this solution, you can also keep track of data in specific tables that you select. So if we go in the list of my objects here, you can see some of my tables are highlighted here. So post types, vote types, link types. So these are basically tables that we've selected as lookup tables. So any data changes that are made to these tables are also captured by our project. So I'm going to go ahead and make a quick data change to one of these tables as well. Okay, again, using SQL prompt and snippets, I insert into, let's say, the vote types table. Let's just quickly see what data we have in there. Okay, so I'm just going to add a new one with ID of 18. All right, let's go ahead and execute this as well. Perfect. So made a couple of changes here. I'm going to go back into SQL Change Automation and refresh my project. So this is basically going to detect those changes that I've made to my development database. So again, I don't need to script anything out manually as a developer. I can see exactly what I've modified, how it's different from what's in our project. So I can see the object differences, as you can see here, and even the data difference in an XML format. So we just added a new record. So now my next step is to say, okay, so I'm happy with these changes. Let's go ahead and import these changes into our project. So I click on the import and generate script. All right. So as you can see here, a new migration script has been generated, 002, under this specific version, semantic version folder. So, and if I take a look at that script, we can see that, first of all, each migration has a unique ID. So we're going to talk about that later on as far as how that's used when it comes to deployments. And here's our script, right? So the alter table, the addition of the column, and then further down here, the record that we added. So now the good thing about this process is we're still using compare to generate these scripts, right? So nothing is generated manually, which is great. But another additional benefit that you get as part of doing this is that we're really shifting left the process of generating the script. So in the model-based approach, we always wait till the point of deployment to compare against a given environment to generate these change scripts, which might be too late if you're, with following the principles of DevOps and the whole, shift left mentality. So we're generating the scripts early as part of the development process, and the additional benefit that you get on top of that is that you can modify these scripts if needed, right? So for instance, if I wanted to add an update script to populate this Instagram column with some default data, so if later on we decide to change this to not null, we don't have to worry about the column being empty. I can just simply go ahead and add my script on top of what's been generated by SQL compare, or just modify the behavior of compare if needed. So that's the other benefit of doing database development this way. But I'm pretty happy with the changes here. Now, the other thing that you also notice is that the store procedure change is not actually in this migration script. That's because using our SQL change automation, you actually have the option to treat your program objects in a state-based fashion. So instead of generating all ultra script for every time a store procedure or function or view is modified, we just simply take the final state of this store procedure, and if it does exist in the target environment, we simply recreate the store procedure. So for that reason, you can see this get post.sql file has been modified, and if we take a look at it, we can see that this is how we deploy the store procedures if you turn this feature on. If you don't turn this feature on, then it's going to treat your program objects through migrations. So every time you modify a store procedure, a new migration script will be generated. The benefit of doing this, so treating your program objects in a state-based fashion, is that you can, minimize the number of migration scripts that you generate, and you can also have a better conflict resolution in source control if, two people modify the same program objects, because we're basically modifying the same file in the project that represents an individual program object. Okay, great. So I've got my changes. I'm just quickly going to go ahead and verify my scripts here. So this is basically doing a test deployment against a shadow database that sits alongside my development database to make sure that the scripts that I have are valid and there is no syntax or execution errors with SQL Server. So everything looks good. So I've got my changes in my project. Now I'm going to go ahead and commit my changes into source control. So I actually have a very simple branching strategy here. So if you take a look at my Git repository here, I have two branches. So master branch and a feature branch. So my workflow is that I make my changes, I commit them into my feature branch. When I'm ready to promote those, I would do a pull request to merge my changes into master. And then once the merge is complete and successful, then I'm going to trigger a build in my CI environment to test what's in our master branch, make sure everything's valid, and then start looking at deploying those out to our target environments. So this is a good strategy for cases when you have, if in your current process you do a lot of cherry picking when you're picking specific change scripts for databases from your development and deploying a subset of those to your test environment and then cherry picking again. So if you find yourself doing a lot of that, that means you could actually benefit from a branching strategy when you're branching by feature or by team or by whatever category that makes sense to you, and merge those when the change is already, so that you don't have to then worry about cherry picking changes from a big set of changes that have been made by your developers. So I'm going to go ahead and commit my changes into my feature branch first. So let's go ahead and commit. Okay, so I'm going to write my check-in comment here. I'm going to keep it short since this is just a demo. And I'm going to commit and also push to my Git repository in VSTS. Yes, I guess we don't need to save these. All right, let's try again. Okay, so pushing the changes to our current branch in VSTS. And that was successful. So now let's go ahead and take a look at our project in VSTS. Okay, so here's my code. As you can see, it's telling me that our feature A branch has been updated. So if I want to create a pull request, I can do that to merge into master. So let's go ahead and do that. Okay, so here's our commit that we're merging the files that are affected. So this is another great thing about doing pull requests, is if there is anyone that needs to review your code before the merge is complete, you can actually either set default approvers or people that you want to, whether it's peers or senior developers or managers or DBAs that you want to look at your code, then you can specify those here. And once you create them, that will get notified that there is some code to be reviewed that is trying to that we're trying to merge into master. And the nice thing about that is that as part of the review, not only you see the scripts that are going to be executed, but also you see how those specific objects are changed. So here I can see how this user table has changed because a new column has been added. So here's how the state of the table is changing, and here's what we're executing to change the state of the table. And similarly with store procedure. So since we are executing the same script for each individual program object, we can see exactly what's changed in the script of that object as part of the review process. So everything looks good. And I'm going to go ahead and create this. Obviously, there is no one to review my code in this case, but so we're just going to go ahead and complete the merge. Okay, and as you can see, our merge completed, meaning that everything got merged into our master branch successfully. So now this should have gone ahead and trigger build in our CI environment. So if you go to our builds, we can see that a new build has just started. So while we're waiting for our build to run, let me quickly walk you through the actual build steps that I've configured for my database here. So let's edit our definition. Okay. So what I'm doing as part of the build process here is I'm using some of the extensions offered by Redgate or plugins from Redgate from our SQL change automation and also our provision tool to orchestrate my build process. So the first thing I'm doing here is I'm building my database from scratch on a temporary database. So in this case, I'm using local DB, which is SQL Server Express. But if for any reason your database cannot be built against SQL Server Express, you can actually specify a specific SQL Server instance where you want this temporary database to get built for verification purposes. So we're not really doing any deployment at this point to any of our existing databases. We're just basically creating a temp database that we can validate our copy of the database against and make sure that all these scripts that we have in source control are valid and that we can actually create our database from scratch as far as the schema is concerned. If you can do that, then we go ahead and package up the database files or our project from source control into a NuGet package, which becomes our deployment artifact. So each build will have a single artifact, which is a NuGet package that is basically locked down and cannot be modified once the build is complete. And those NuGet packages is what we will be deploying from later on as part of our deploy process. So if I can verify my database and make sure it can be built from scratch, the next thing I want to do is to make sure this project or the current state of my project can be successfully deployed against a copy of my production database that has all the data. And again, to do that, I'm doing a similar thing to what I just did earlier on when I spun up my development environment. So using our clone extension, I'm creating a clone called Stack Overflow build, and then I'm doing a test deployment against that clone to make sure that I can successfully deploy my changes against the copy of production, and then finally delete the clone. So again, you saw how quick it is to spin up a clone of a database regardless of the size. So even if you're dealing with a terabyte database, you can just quickly spin up a terabyte database from your production, do a test deployment against that database, and if it succeeds, then you continue with your actual deployments to your target environment. So again, you're probably sick and tired of hearing the term shift left, but that's exactly what we're doing here. So we're shifting left the testing of production readiness of our changes. So here, if my build succeeded, so let's go back and verify. So you can see my build succeeded, meaning that I'm able to build my database from scratch based on what I have in my project from our master branch. I can also deploy that successfully to a copy of our production that has all the production data in it. So this gives us, greater I guess comfort and confidence in that our database is in a good state, and our project is in a deployable state that we can easily roll out to our target environments without having to worry about failed deployments or anything like that, because we verified that as part of our build process. So now that my build was successful, I want to go ahead and now deploy this to our higher environments. So I'm going to go ahead and create a release off of this build number 292. Which will then start deploying to my target environments. In this case, my target environments are also clones. So you can see here I have Stack Overflow testing, Stack Overflow staging, that are copies of my production environment, and they're only, again, taking up this much disk space. This is another great thing about this cloning technology, is that you can easily refresh your test environments as frequently as you want. So if your test environment is not in the right state because some other people did a deployment, and whether or not it failed or succeeded, we don't care, but we want to test against a true copy of production. So we spin up or refresh our test environment in just a matter of seconds using this technology as well. So these are the database that I'm deploying to, and then I have my production database sitting on a different server that we will be deploying to later on. Okay, so let's go to take a look at our releases. So we just created a new release, number 14, and as you can see, it started the deployment to our testing environment. So let's go ahead and take a look at that. Okay, so it looks like the deployment to our testing database succeeded. So I'm going to go ahead and initiate the deployment to staging. And while I'm doing that, I'll quickly show you my release definition for our deployments here. So again, as you can see, I have three target environments: testing, staging, and production. And if you take a look at the tasks here, again, I'm using our SQL change automation extensions to define my release steps. So 2 steps. The first step, I'm basically creating a patch script that is specific to that target environment. And we do that by by analyzing this table that we add to your target environment called the migration log table. So, and that's where that migration ID that I showed you earlier on comes into play. So each migration script has its own unique ID, and we use a table in your target environment to keep track of what we've already deployed to that specific environment and what changes are pending. And then based on the changes that are pending, we create a patch script as part of this step. And then as part of the second step, we deploy that patch script. So the good thing about breaking it down into 2 steps is that you can introduce a review step if needed. So you can review your changes either through a manual intervention step or as part of your release, or even for post-release review processes. Like if you want to go back and see what you deployed as part of a given release, you have that information in hand to look at. So, since our deployment to our testing environment was successful, let's go ahead and take a look at that patch script that we generated and a report of what was deployed. So I actually saved those off to disk. So let me go ahead and pull that up. Okay, so here it is. So we just did release 14 to testing, and it looks like staging completed as well. So let's take a look at the testing report. So an HTML file gets generated. And here's a report of the schema changes that we've applied to the testing environment. So first of all, you can see what objects have been modified and how. So you can see we've added this new column to the users table. We also modified the store procedure by adding a column to the select statement. And if there's any warning such as risk of losing data, dropping columns, indexes, tables, so any modifications that can result into data loss, you will see a warning for those here. And finally, the actual script that we put together using SQL CMD. So this is that patch script that I mentioned. So only includes the changes that are pending against that target environment that we've deployed to. So if you go past these variables that we use for our builds and releases. So we start off by making sure SQL CMD is enabled and doing all the checks to make sure that we can actually start executing our script. And then our script is ordered by pre-deployments first, if you have any pre-deployment scripts, and then your incremental scripts that are pending against the target environment. So for example, here is the migration script that is pending, which is that migration script that we generated from our changes that we made into our development environment. And that migration script is complete, and it logs it on the migration log table that I mentioned and marks it as deployed. And finally, if all the migration scripts are complete, then we move on to the programmable objects and only deploy the programmable objects that have been modified. And in this case, we only have one program object that has been modified, so we're basically redeploying that. And once we're done with the programmable objects, then we do the post-deployment scripts, and if they all succeed, then our deployment is successful. If not, then everything is wrapped up in a single transaction. So if any of these changes fail, then the whole transaction is rolled back, so you don't need to worry about your target environment being in an inconsistent state as a result. So again, this is basically that reliability, how you can make your deployment process more reliable is by keeping an audit trail of what has been deployed and relying on these reports to review your changes and make sure everything looks good before a change goes out all the way to production. So if you take a look at our releases, we can see that our staging environment was also deployed successfully. So I can go ahead and now deploy this to our production. So the main difference between my deployments to production and the lower environments is that I have that review step built into the production deployment. So once it creates our report, it's going to stop the deployment and let us know that there is changes or deployment for us to review. We'll take a look at that report that we generate. If everything looks good, then we'll go ahead and deploy to our environment here. Okay, so as you can see here, it's now telling me that there is pending intervention. So it's asking me to review the releases. So I'm going to go ahead and take a look at the releases, the release report to our production environment. Okay, so no surprises. The changes that we have deployed. Quickly skim over the script here. Okay, so I've got our incremental scripts, our change scripts, the programmable object here at the bottom, and looks good. So I'm now going to go ahead and approve this. So it can now get executed against my production environment. All right, looks like it's almost complete. All right, so we can see our deployment to production also succeeded. So that concludes our demo. Hopefully as part of this demo, you're able to see how you can utilize our solution to easily spin up your environments and be compliant when it comes to data regulations, and also be able to move your developers away from shared development environment and help them have their dedicated databases with full access to full copy of the data from production by having the sensitive data masked. And we also were able to see how you can source control your database changes, create your projects, and also how you can run automated builds and test against the database before you start deploying out to your higher environments. So I'd like to, so we still have a few more minutes here, so I'd like to move on to questions here. So let me go ahead and pull back the slides. All right, so let's get to questions here. So I'm just quickly gonna pull up the questions list here. Okay, so some really good questions. So I'll start up with the first question here. So the first question is, how do we keep permission setting changes from migrating up? We have permissions specific to our dev environment that we do not want to migrate, but they are always detected as a difference. So so really good question. So using the projects, you can actually specify a SQL compare filter. So we actually have a documentation for that. So I'm actually going to go ahead and pull up the documentation and send it to you post the webinar. So you see how you can do that. So the idea is that you in SQL Compare, you have different options for filtering, users, role memberships, and things like that in your database. So that way, when the comparison happens, it doesn't pick up on those differences that you might have on users, roles, permissions, or anything else. So you can apply a filter, and you can also use some of the SQL Compare options on specific things that you want to ignore. So again, user permissions and role memberships is one thing that is a very common option that most of our clients apply. So you can also apply the compare options to your project. So so I'll share with a couple of links that goes over those in a lot more details after the webinar, and we'll email it over to you. All right. So the other question is, did you track insert into with the import and generate script? Yes. So let me just pull up my project again. So let me just start presenting real quick. So yeah, so the first thing you need to do is to first of all specify the tables that you want to keep track of in terms of data. So you can go to this list here and right click on the tables that you're interested in, say include table data. Once you've done this, then this will generate a baseline script for all the data in your table, and that will be saved as a migration script. So my baseline script for my data, I believe it's sitting in one of my folders here. So it basically says checks to see if any of that existing data exists in the target environment. If not, it will create the baseline of your data. So for example, if you're deploying to an empty database, it will run that baseline of the data to apply all the existing data, and then apply any additional migration scripts that you generate for your insert scripts or updates or deletes using the import and generate script option here. Okay, so let's move on to the next question. So another question. So we have a team that is working on some major changes that have been migrated to the staging environment, but they aren't ready to go to production for another 2 weeks. Team B is working on a production issue and need to migrate their hotfix to production today. How do they keep everything straight so Team B's migration goes to production without bringing Team A's changes with it? So this goes back to the I guess your branching strategy that you've set up. So if you run into cases where you deploy some changes to a given environment, and but you also have a hotfix that has to go to production straight away, then you would need to have a branching strategy that represents where you have a branch that represents what's in production. So basically, you branch off from a branch that represents what's in production, you apply your hot fixes to that, and then you merge it back in to that branch that represents what's in production, and that basically, and then deploy from that specific branch to production. So it all goes back to your branching strategy, and this is not specific to databases. The same principle applies to application code. So you could have kind of release branches or release candidate branches that you take to your target environments, and then a final release branch that is specifically for production. So you can merge into that every time a specific branch is ready to go to production. So that way you don't, if release candidates that you've deployed to staging are not in production yet, then those release candidates aren't deployed as part of that release of your hotfix, if that makes sense. So another question is, so you showed the demo with VSTS. Are the tools available in AWS? So AWS, as far as I'm aware, they or maybe I haven't seen it, but as far as the workflow that I've seen with AWS is that you still utilize specific build and release systems in a whether in AWS or on-prem, doesn't matter. So I've seen people working with Jenkins, working with TeamCity, and other build and release systems, which we totally support, and then deploy to databases that are in AWS, whether it's RDS or a SQL Server sitting on a VM in AWS. So yeah, so it's totally doable. Again, AWS provides you with the infrastructure. You can obviously go with any build or release system as part of that for your projects, and you can also deploy to a database in AWS as part of this. So the other question is, when is a model state-based approach recommended? So really good question, and I'd mentioned I would go over this in more detail, so thanks for reminding me. So the scenarios where I would use model state-based is when you're doing, straightforward schema changes, a lot of store procedures, a lot of program object changes, not a lot of data migrations or refactoring changes to tables where, you need to do, handle data changes as part of that. So if that applies to you, then the model-based is something I would recommend because, it's more straightforward. You're just keeping track of the state of your objects and then just relying on a compare engine to generate the scripts later on for you. Whereas migrations is more applicable to scenarios where you have where you do a lot of data migrations, you want more control over the behavior of compare, or if you're doing a lot of refactoring changes to tables where you're modifying columns and you have to deal with the existing data in those columns as part of that rollout, and things like that makes the migrations approach more appealing because you have more control over how you want certain changes to be deployed, and you have control over what kind of data scripts you want to incorporate into those schema changes that you are planning on rolling out to your target environments.